think time to start, almost perfectly on time. So first of all, welcome everyone, and thank you for joining our today's session about fire regulation for green walls. While I do my introduction, you can still fill out our polls and tell us where you're from, what your professional background is, and if you joined the session before already, so we have a perfect overview. But first of all, a very warm welcome from my side on behalf of the EFB. I am Isabel, I'm administrating the EFB, and I will moderate today's webinar session. And before we start, I would first of all like to thank our general sponsors that allow today's session to be for free for everyone. And first of all, Jakob Prop System, Karlstahl, Greentex, Walgreen, and Terapia Urbana. A very, very huge thank you to those sponsors. Also a few administrative things in the beginning. First of all, the webinar will be automatically recorded, but don't worry, all participants are not visible, so no issues with seeing faces or not. And after the sessions, once we elaborated everything, it will be available on YouTube for free. For questions, as some people already did, please use the questions section on the left side. We will gather all the questions for the very end, and then we will ask them to our speakers. As well, on the left-hand side, below the polls, you should be able to see the handout that can be downloaded. So in case you want to have a look at it separately, you can download it and use it. And in case you have a black screen or any technical issues during the session, please try to use a different browser or check your internet connection. Sometimes this might cause some issues. Regarding the agenda, what will today's session be about? First, I would shortly introduce the EFB and our speakers, and then we will get an insight about the research in Austria, how it all started, and how the regulations developed from there. Then we will see how it further established also in Germany, and we will end up with a conclusion and an outlook regarding the regulations. And then in the end, I will ask your questions to our speakers and hopefully get all the good answers to them. About the EFB, so the EFB is the acronym for the European Federation of Green Roof and Wall Associations, which was founded in 1997 as a non-profit organization. The EFB is an umbrella organization for green roof and wall associations in Europe. Actually, currently, we're already 16 national associations, 2 from Spain, that are actively working in the EFB. And what is the EFB actually doing? So we're supporting and guiding policy implementation processes in the field of building greening. We're encouraging and sharing research activities, we transfer knowledge, we organize events, we promote the technology of green roofs and green walls and also green infrastructure in general. And we try to make our cities throughout the world even greener. So yes, if you have ever an interesting topic or research project that is concerning the fields of greening buildings, please always reach out to the EFB. Today's speakers, first of all, we have Dipl Werner from the Department of Testing, Inspection and Certification of the City of Vienna. And then we have Julia Noder-Schaab speaking, who is a civil engineer and is part of the German Association BuGG. But I'm sure they both will introduce themselves into more detail. So now I would like to hand over the word to you, Dieter. I hope it's already working.
Yeah, I think so.
Yes, and the floor is yours now. Thank you.
Thank you, Isabella. Thank you for the invitation and the chance to talk to you today about such a controversially discussed topic like green walls and fire regulations. First of all, I may say some sentences about my professional background, about the Municipal Department 39. As you can see, we are a part of the City of Vienna administration, but I always say we are a big civil engineering bureau with a very wide range of topics and activities. Our department is built on 4 columns. Our column today is the construction engineering column, where I am the head of the building physics lab, dealing with fire protection, thermal insulation, and sound insulation, the classical building physics topics. We have also a testing and inspection department dealing with hygiene topics, which means to examine the drinking water of Vienna, for instance, or the water of the Danube. We also have a radiation protection lab dealing with radiation protection, as it says, X-ray apparatus, and so on. And in between, we have the certification center, where all the certificates are edited. The department consists of 155 employees, and we edit about 12,000 reports per year concerning testing, inspection, and certification. So very wide range, and this wide range bases on about 800 different test standards, inspection standards, and certification standards. So we are accredited for about 800 standards, which shows you a very wide range of activities. Of course, a testing institute has to have a quality management system, an environmental management system, and also has to be member, for instance, of eGolf. That's the organization of fire testing labs in Europe. We are recognized as testing institute in Germany, for instance, and we have the chairs and participate in numerous national and international panels concerning European standards, concerning national standards. And within the construction engineering column, as you have seen it in the slides before, we deal with, for instance, lighting technology, the picture on the left-hand side. We deal with strength tests, the picture, the image on the right-hand side. And in my lab, as I said before, we have sound insulation, image on the left-hand side, where we test sound absorption, air sound insulation. And on the right-hand side, you see one of our furnaces in the part of fire protection, where we deal with fire resistance of building products. And we also test the reaction to fire behavior of building materials. And today, our topic is fire and green walls. So that will be the content of the next 15-20 minutes. I will show you the history of fire tests of facade greenings in our department. I will show you the main results of these tests. And I will show you the way from the results to the development of fire regulations in Vienna. First of all, the history of fire tests concerning green walls, facade greening. This history starts in, I would say, 2015, where the Viennese politics said we have to do something against urban heat islands. We have to do something against climate change. And one means is, of course, to green the city. So the City of Vienna administration tried to force green walls as one mean of that. And in 2015, we as the testing center were asked by the politics, what do you say about the fire behavior of green walls? So we did a short literature research, and within this research, we found nearly nothing about the fire behavior of green walls. So we said, let's try it by ourselves. Let's try to put a green wall, a facade greening, onto our test rig and make a fire test. This was in 2015, and to say the basis of these tests were always the standard tests concerning facade systems, because in Austria, as in nearly every other European country, we have fire protection goals concerning facade systems, concerning walls. So we tried these first fire tests onto our test rig according to a national standard. The standard you see here, it's the ÖNB 3800 Teil 5, 3800 Part 5. That's the national facade test standard for fire tests. Very similar to the DIN test, to the German test. Not very similar, for instance, to the British test, to the French test, or to a Swedish or Norwegian test. Because in Europe, we do not have any harmonized facade test concerning fire tests on facade systems. So we took our national test standard, we took our national test rig, and put on that test rig Ivy. Why Ivy? Because in the literature, Ivy was always described as the worst case concerning fire and greening. Maybe because of the content of wood, maybe because of the content of oils inside the leaves of ivy. So we put ivy on our national test rig, and on the next slide, there you see the test rig. Before the test, you see the ivy. You see the fire chamber on the image left-hand side. That the fire chamber is situated in the inner corner of the test rig. We have a short wing and a wide wing, a long wing within this test rig, and the test rig is 6 meters high. And in the inner corner, we have this some kind of simulated window. There you can see the wooden crib. That's the fire load defined in the test standards. It's a 25 kilogram wooden crib. And you see the ivy. The ivy was mounted directly onto the test rig, which consists of aerated concrete. And the ivy was mounted mechanically with clamps and with nails onto the test rig. Vital ivy. And in the other images you see very near to the, also mounted very near to the fire chamber. And then we ignited the wood crib, as we do it in a standard test too. And these were the scenes that can be seen. So there you see some kind of ignition of the ivy, some kind of flash over, I would say, directly above this fire chamber. These flash over scenes, they last for about 5 seconds, 6 seconds, 7 seconds. very short, but the flames, as you can see, reached the top of the test rig, which is 6 meters high. So we had flame length of 6 meters, 7 meters, and more for a very short time. But these are scenes and these are images that do not fulfill our fire protection goals on normal, on standard facades in Austria. Because this flashover may lead to fire propagation over the facade, and this is forbidden in Austrian regulation. So seeing these images, a negative result would be the outcome of this test. These images show us the damage after the test. Very interesting, the image on the right-hand side, where you can see the nearest part to the fire chamber, and there you can see nearly vital ivy. So this flashover was directly above the fire chamber, and we had no lateral flame spread left and right. The flashover was directly above the fire chamber. So this was the first test, I think worldwide, the first test in a lab on a standard test rig. And it showed us, principally, there is the possibility of such a flashover. So the solution was not a very easy one for the question the politics asked us, and we had to do further studies. The next study, the next examination, was an examination in muffle furnaces, so in some kind of small tests, small fire tests, where we put different plants, different woods, different leaves of plants used as facade greenings into such muffle ovens, into such small furnaces. And then we did some temperature programs within the furnaces and examined properties such as smoke production, as smoldering, and as ignitability temperature of these plants, of these woods, and of these leaves. What was the outcome? What was the result of these small tests? Wooden parts showed an ignition temperature of about approximately 570 degrees, and the leaf masses of the plants showed an ignition temperature of about 650 degrees Celsius. We also saw that every plant tested could be ignited, and every plant has a part in it that could be ignited. So the first idea was to set up some kind of reaction to fire class for plants. So this was not possible. Unfortunately, no. As you can see on this slide, we cannot say ivy has the reaction to fire class E, for instance, and different plants have reaction to fire class B and could be put on higher buildings. This dream idea was not possible to realize. So we had to go on with our large-scale tests, and we had the opportunity, with the help of the financial, especially the financial help of the City of Vienna, to do 3 major research projects on our large-scale test, on our test rig that you have seen before. The first package was dealing with ivy again, was dealing with plants put onto climbing aids and was dealing with climbing aids put at various vertical distances from the fire chamber, in front of the fire chamber. You will see the images immediately. The second package, the second research project, dealt with ivy and putting in some construction fire barriers. We were also dealing with climbing aids in front of the test rig, as I said before, and we also put metallic trough systems onto the test rig and to examine their behavior. And within the third package, which was done in 2021, we examined greening in connection with attic systems, with thermal insulation systems onto walls. So let's look at the results. There you see some images of the fire tests with the climbing aids. Here you see the climbing aids directly mounted onto the test rig, and the plants directly onto the climbing aids. And you see a very similar behavior of the plants as you have seen it before with the ivy. There we also examined this kind of flashover I showed you before. So there's no difference between plants directly put onto the test rig and plants put onto a climbing aid. And these climbing aids were made out of steel, and these climbing aids put onto the test rig. So nearly the same behavior. Afterwards, we put the climbing aids away from the fire chamber. On these images, you see the climbing aids beginning 1 meter above the fire chamber of our test. And you see in the middle, you see the flame of the wooden grip, and you may see that the flame now doesn't reach the greening. We do not reach this temperature I've shown you before of 500, 700 degrees Celsius. So we have no problem with fire propagation with ignition of the greening. So putting away the greening from possible fire loads is one mean possibly to fulfill the fire protection goals on facades. Second project, ivy now with fire barriers. Fire barriers made of steel. You see these fire barriers directly above the fire chambers. We have here fire barriers made of steel, 1 millimeter thick, and with a depth of, I think these are 30 centimeters. And you see the function of these fire barriers in the image in the middle. The flames are getting away from the facade because of the fire barrier. Fire barrier deflects the flame away from the greening, away from the facade system, and we have no ignition of the ivy directly put above the fire barrier. So maybe another solution found. These are images from the tests with the climbing aids put in different distances from the fire chamber, in front of the fire chamber and in certain distances. In the image on the left-hand side, I think the distance is about 1 meter between the climbing aid and the plants and the fire chamber. In the image in the middle, I think these are about 30 centimeters. And in the picture on the right-hand side, I think these are 10 centimeters, putting the climbing edge away from the fire chamber. And as you can see, the 1 meter in the image on the left-hand side is a very secure and safe solution, to say it in this way. The 30 centimeters is maybe a solution, and the 10 centimeters on the right-hand side is no solution, because the plans again show these flashover scenes. Trough systems. Here you have metal trough systems made out of aluminum. Left-hand side, fire barrier, but I would say that's the fear solution, with depths of fire barriers of about, I think, 70 centimeters, 50 centimeters. That's not necessary, these depths of fire barriers. In the middle, you see fire barriers with 30 centimeters, 20 centimeters, and in the picture on the right-hand side, no fire barrier. And there you can see that the metallic troughs alone, they are not the solution, because also in this situation, with the metallic trough systems, we saw this kind of flashover. We saw this fire propagation through the plants, the greening. And as I said before, the third research project about thermal insulation plus greening. So the background, the idea about these tests was, you have now thermal insulation on the building, and afterwards you put greening on it. Is there any change in the fire behavior of the attic system? In the image on the left-hand side, you see the attic system in white. And we mounted the greening system in this test, also metallic trough system, directly onto the attics. I think on the next slide you see the results of these tests. Yeah, here you also see tests with the climbing edge in the distance we detected before, distant to the attic system now, and you also see the distances we examined before are the right distances also when you have an attic system on the facade. And it was also shown that the mounting of the greening doesn't influence the fire behavior of the attics in any negative way. So from our point of view, the main results were, we have no lateral fire propagation because of the greening. As you see the image of the ivy, the damage of the ivy after the test, not even close to the flame directly next to the fire chamber. We have the chance to have a vertical spread over of fire through a brief, a few seconds ignition. As I said before, some kind of flash over. That's possible. Positive, we have no risk of secondary fire from falling burning parts, because in very many European countries, you also have the fire protection goal, no secondary fire because of falling burning parts of the facade systems. So that's not the theme for facade greenings. And we had no indication that greening leads to any deterioration of the attic system, of a thermal insulation system, which is already on the facade. And afterwards, after these tests, in summing up, these were about, I think, 25, 30 tests. we have now conducted out. We started the discussion with other departments of the City of Vienna, especially the Building Authority Department, and of course the Fire Department, the Firefighting Department, and put these main results in some kind of guideline leading to fire regulations, which should give the possibility to realize facade greening, but in a very safe and secure way concerning fire topics. The regulation consists of two parts. We divide the regulations in regulations concerning very low buildings and on the other hand concerning higher buildings. And that's already the same in all European countries. So now we say for buildings up to building class 3, which means in Austria nearly 3 stories, no special fire protection measures are necessary. We have to prove only the reaction to fire of construction, for instance, of the troughs, for instance, of the climbing aids. Excluding, of course, the plants, because plants are no building products, so we have no reaction to fire and no other properties here to test. So up to building class 3, no problem, no special fire protection measures. Going into buildings, building class 4 and 5, which means 4 stories, 5 stories, we have in Austria additional protection goals, fire propagation and falling down of large parts of the facade systems in a case of fire. And there we defined you have to test according to this national test standard. You have to make a distance to combustible roof structures of vertically minimum 1 meter of the greening. The background of this regulation is that we don't want to have, in case of fire, that the fire propagation of the greening leads to a fire propagation into wooden roof constructions. But we also have some kind of greenings which may be realized without further testing. These are greenings with maximum 3 stories high, or you put in horizontal fire barriers. For instance, these steel fire barriers you have seen in the test. And you have put them, of course, in every story above the windows. Or you have some kind of protective distances. We call them now 2 openings where a fire may exit out of a room onto the facade. So maybe to understand these words better, we also have put some images into this fire regulation guideline. And on the image on the left-hand side, you see this solution with the fire barriers. So you have to have fire barriers with a certain depth, of course, in every story, put in every story, and you see the vertical distance to the roof construction. If you don't want to put the facade greening directly above the window, no problem. Because if a fire exits out of a room onto the facade, we have the problem only, as you have seen it, directly above the window, not left and right. That's the image in the middle. And on the right-hand side, you see the solution with the climbing aids in a certain distance away, for instance, from a balcony, from a terrace. And we have also defined a general rule in these regulations. At any time, the facade greening has to be kept in a vital functional condition. This needs, of course, necessary care measures and, of course, the definition of responsibilities. You may now say these are very naive regulations because the definition of responsibility is a very difficult regulations. But it is stated now, and I think that's the only way that facade greenings will work in terms of fire. And maybe because the argument against this care and these responsibilities is very often the costs of the care and the of the facade greening in the years after putting the facade greening onto the facade. So another project of our department is to make quality checks with drones. So to lower the costs of the monitoring of the green facades. And that's a very new project our department is now developing and our department is now working on. And of course, some facade greenings do exist in Vienna. Here you have some images about facade greenings in Vienna. Trough systems, climbing aid systems in the picture on the left-hand side, trough system, right-hand side, and directly wall systems here. So I think we won't have a Bosco Verticale in Vienna, but I'm quite sure we will have much more of these construction, much more of facade greenings within the next years in Vienna. We need them. There are wide positive effects about facade greenings, but we need them also in a very fire-safe way. And I think we have now created the basis for these fire safety regulations. Thank you very much.
Thank you very much, Dieter Werner, for sharing your experience with us and all this interesting information and results. I think everyone could get a good overview already. Please do not forget to use the question tool to ask questions that I will address to our speakers at the very end. And now I would like to hand over the word to Julia, who will give an insight about the development of the regulations in Germany and also some research that she did there.
Hello, I hope you can hear me. I need a sec
Yes.
to start my presentation. So, my name is Julia Noder-Schaab. I'm a civil engineer working at the company Fire and Timber ING. We're working on different projects. We focus on assessment of fire safety for different buildings like schools, kindergarten, residential and office buildings. And we also focus on complicated and special timber construction. That's why we're doing. In addition, I represent the association Bundesverband Gebäudegrün, where I respond for the topic fire performance of green roofs and green facades. So let's talk about how we handle this topic in Germany. We started with the research in Germany after we got familiar with the published results from Austria. So we love to talk about all our results, and of course, everything happened after the first part of results in Austria. So the first research project in Germany was actually my master thesis, fire performance of green facade. It happened at the TU Munich in 2019. About current and future project, I will talk at the end. So first of all, we should focus on existing and non-existing regulations. In Germany, we like to compare green roofs and green facades. So we have here different situations, like because the greenery is attached to the building, we have to follow the rule. It called State Building Code, and we have to follow all supplementary regulations. For green roofs, we have technical buildings regulations, so we can receive the required proof. For green facade, we don't have any technical building regulations, so we cannot receive any verifications. That means if you like to attach a green facade to a building in Germany, which is higher in total than 7 meters, we have to do special individual proof. It means like you have to prove the impact of the green facade on the whole fire safety of the whole building. So you're doing this individually in this, and this, I would say, this individual evaluation of risk is a very German way. And yeah, let's see what we did in Germany in this past years. And about the individual risk proof, I feel like, in my opinion, that's the main difference to the regulations of Austria. So these regulations need some research. Okay.
Julia, ganz kurz, kannst du unten auf Ausblenden klicken, weil das verdeckt die Folie ein bisschen.
Perfect. I did. So, the outcome of my master thesis was 4 fire performance tests based on the German standard DIN 4102 Part 20. And the Part 20 introduce and define materials for the buildings and different components for buildings. So you can see on the slide the chosen plans for these 4 burning tests. And also, I would say that this Part 20, like this standard, is introduced for supplementary verification for assessment of the fire behavior of all external wall claddings. So they did it for, like, in general, we have the standard, and then we started to use it for green facades. So yeah, the aim was to prove facade greenery without any provisions to prevent fire spreadings across the whole test object. We evaluated 3 of 4 results positive because no uncontrolled fire spreading could be confirmed, and that's why we decided to evaluate and describe what we did, especially the result of the plant wisteria showed that green facade can be fire resistant and as conventional facades, even though we have essential oils and biomass of the plants, and they are flammable, we still could achieve this positive results. So let us watch some videos. Like, first I'm going to show you the fire performance of the plant wisteria, and Yeah, let me stop for a sec the presentation and show you. I'm showing you this. Mhm. 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 Here we go. That's the plant Wisteria. This fire performance test happened in 2019 during my master thesis. And like you can see, there is no vertical or any horizontal fire spread. Um, and the test like late 20 minutes. And in this time, the whole plant dried, it dried out without catch the fire. That that's what we saw and how we evaluated. We said it was completely like positive result. And yeah, here you can see a little bit how it happened. Yeah, at the end of 20 minutes, of course, we stopped the test, and the fire, like the chamber, was turned off. So let's watch the second video. I'm sorry, it's always not working in the right moment. Today is I'm so sorry. Now it should work. This one. All right. So this is fire performance test of the plant Inomius coloratus, or we calling it sometimes winter creeper. So you see there is some vertical fire spreading. The same, there's no horizontal fire spreading at all. And of course, we waited what gonna happen in this 20 minutes, especially what is the damage, and we asking ourselves like if any vital biomass of the plant will survive. So you can see here how it's going. Now it's 7 minutes, and then we waited 12 minutes. Yeah, the fire started. That's really impressive because it stopped like on one point. Despite the fact it's still the same fire coming from the chamber. Yeah, I'm glad we watch it. I thought it's maybe a good thing to show you a brief video how it happened. And now let's go back to the presentation. I know. So, yeah, in addition,
Ausblenden.
yeah. In addition, I thought I want to show you some pictures, like fire test before, after 12 minutes. Let's do it like this. Before, after 12 minutes, after 15 minutes, the highest point where the fire could be confirmed, and how it looked like after the testing time ended. So, like you can see on the last picture on the right, you can see damages, but you also can see the vital biomass and leaves on the top. That's that was surprise for us. In total, you have a high. Maybe it's not that easy for you to read it, but here we are at 2.5 meters. So it's from the chamber on begin. It's 3 meters high. And an uncontrolled fire spreading would mean no vital biomass would survive the burning test, right? So, if you are interested in all results, They are published and you can find them in this link on the bottom. I just want to give you a short brief. I didn't explain the whole burning test because the standard part 20, which I was talking before, it was introduced in Germany and it's really familiar to this, like the same way how the colleagues in Austria did the burning tests in Austria. Like it's the same amount of wooden in the chamber, and of course it's because it's a master thesis. It's a little bit simpler. So I had a budget and I need to do it in this way. But I would say the important thing is we used really big grow plants, and like you saw before, the plant wisteria, it grows like for 6 years in total. So it's not like a plant which is only 5 days old. So you have a real situation, and we really try to give our best to prove it in this way, like I show you. And yeah, I would say like I really want to show you how we started to use our knowledge, which we which we achieved from this burning test from Germany and Austria. So all results summarized. Since 2020, we have in Germany the specific recommendations of the Federal Fire Department. They introduce different solutions how to build green facades and how to prevent fire spreading across the wall. They showcase the system. They showcase the system in the 6 drafts. On the left side in the picture, you can see some fire barrels. On the second picture, you can see some fire barriers, like this steel sheet fire stops, we call them sometimes, on the top of each window, and then other solutions which are really familiar to the solutions in Austria. So they are like there's like space or floors without any greenery. We have some space here with 1.5 meter to the side, and of course we have just a part greenery. Yeah, so here you can see the special way how we handle the greenery for buildings, like I said before, there which are higher than 7 meters. Yeah, so after we know the law, we know there are no technical building regulations for green facades. We know we started our research in Germany and did until now only 4 fire performance tests, like the big one, and which were published. At the end, we have the specific recommendation from the fire department. And of course, because we don't have any technical rules like really published, we need to prove this individual, like I told at the beginning. So let's see the general recommendation. And the conclusion for today is, before we build a green facade in Germany, we have to observe the law, the general recommendation for the greenery, like the maintenance of facade greening. We have to know the standards for the growth support system. They are usually non-combustible material, like we used to use, and provisions to prevent fire spreading across every rear ventilated facades. So they need to be built fire barriers between the floors. In the future, we will probably have further recommendation. We are working, for example, on systems without any steel sheet fire stops, without any fire barriers. And we want to figure it out, what is the impact of greenery on timber facades. That's now in process. So I can tell you what we're doing right now, but unfortunately, not that many things are published. That's why we are in process right now in Germany. Yeah, here are some examples, some pictures of the famous green facades in Germany. And as you can see, all of these green facades are influenced by their specific recommendation of the fire department, which I show you before in the 6 drafts. So you can see there is sometimes like part greenery on the side, just below the windows, or you have this clear structure where we, like, in this way we can prevent any uncontrolled fire spreading across the whole wall. And you can see this skyscraper, it's going to be higher than 60 meters. It's going to build in Munich. It doesn't finish now, so it's just a draft from the architecture, and that's how it's going to look like. So we have this special clear structure, and they really did some burning tests which are not published, unfortunately, but they prove it. So they gonna be non-uncontrolled fire spread at all, because all floors are separated from each other in this way, with this construction, like concrete construction, prevent fire spreading across the greenery. Yeah. After you saw a couple examples, let's talk about the current and future projects. We have this fire safe green project at the TU Munich. It's a really big. So like you can imagine, we started first with my master thesis in 2019. Then because of COVID, there was a break. And now in 2021, they hop on the train and started a big research project where they're gonna prove different type of plants in SPI tests, so small testing, and then they're gonna do big fire performance tests like I did in 2019, but exactly based on this German standard DIN 4102 part 20. And the budget is way more higher this time, so they really can prove different plants and different systems. Like I told at the beginning, there are other research projects in Germany, but yeah, unfortunately, the results of this project are not published yet. So maybe we have additional webinars in the future. Maybe we can talk about this master thesis, which is from 2022. So the results are not published yet, but it's really interesting to see how is this impact of the greenery on wooden facades, like on wooden constructions. That's what they try to investigate in this master thesis, in this big project. And I'm sure it's super interesting, but I cannot tell you more about this. I mean, yeah, we need to wait. That's it so far. I appreciate to be invited to give this talk today. And let me know if you have any questions. If not right now, you can send me them per email later on. Thank you very much.
Thank you, Julia. Thank you for this really interesting insight also in what is happening in Germany and what you did so far. I think many people came up with some interesting questions. So I would ask both of you now to please answer. I'll take over the screen. Please answer the questions that we got from the audience. Just a moment. Okay, just a second, please. I hope you can see my screen now. So the first question was to you, Dieter Werner, whether the results are published in a paper.
The results of the first 2 projects I show you, they are already published. I think the best way will be, Isabella, if I send you the link and you send it out.
Yes. So I can send it to the participants, and in case somebody got forgotten, please just contact the EFB office and I will share the results for sure. Thank you. Perfect. Then another question was if there is a digital system for monitoring green roofs and green walls.
So the images I showed you about this smart green monitoring project, they are out of a digital systems. Yeah, we create some kind of cloud, point cloud. I do not know exactly the English word for it, Punktwolke, point cloud, maybe, with the drones and with some kind of artificial intelligence. We, for instance, examine the vitality of the plants and the area where the plants are growing. So this is some kind of digital monitoring system, I think, for green roofs and green walls.
Perfect, thank you.
I hope this answers the question of Rolf.
Then I think something that you actually mentioned, but maybe you can further elaborate or tell it again, whether there have been experiments on other plants apart from ivy.
Yes. Other plants were Acacia, Bartonetsis, Hydrangea, and Wisteria. Maybe Isabella, you know the English words for
No,
for that plant.
Not really. I'm sorry, but at least these are the Latin
these are
names.
The botanical names. Yeah. Acacia, Bartonetsis, Hydrangea, and Wisteria. But we have one proof. Ivy is the worst case.
Yes, as you mentioned in the beginning.
Yeah. That was described in the literature in the right way. Ivy is the worst case in all of the fire tests.
Yes. Perfect. Thank you. Another question about the testings, probably to both of you. If there has been any tests on new wall-based facade greening, not only on the ground-based systems as shown in your pictures. So on the living wall systems.
Living walls.
Yeah.
Not in Germany.
In Austria, you have seen these metallic draft systems. They are some kind of facade-bound systems, but not classical living systems with supporting construction or substrate construction and so on.
Okay. But I guess probably in the future there will be testings also on those systems since they appear quite often.
Actually, I don't think so, because you can imagine, so we have many different systems, and of course it is really important to prove the materials and the components which are not plants. And then after they are proved, they got some verifications, so we know exactly how we can handle them. And then, because there's usually air in the back of the construction necessary to have this airflow, we have, of course, these fire barriers. They are like required, like usually by the law. It's not because of the plants, it's not because of the greenery, just because we have this airflow. So we have this fire barriers between the different floors on the building itself. And then, because we really focus on the plants and a worst case like the ivy, we want to figure out how to handle plants. So what we need to do, so they're going to stay vital, they're going to be like a vital biomass, not dried, not dead. And then we can, like summarize both knowledges and then say, okay, that's a safe system without to prove each system itself. Just to have this knowledge. And like you can imagine, for this big living walls, usually we have not small plants, but still they are like different plants. They are like each next to each other growing, like herbals and all these different things. And usually they don't have that big biomass. So that's a really smart system how it show a big greenery without to have too much wood and timber, anything else in this construction. You just have the leaves and the short part of the plant, and that's it. So the biomass in total is not that high. That's my opinion. I feel like Dieter confirmed.
Yes, it's much more important to prove the reaction to fire of the components concerning the wall bound systems, the wall systems, than that one of the plants.
Okay, great, thanks. A question from a company in Spain that produce greening systems. Is there any experience comparing the performance of different constructive living wall systems?
I think this question is very similar.
Yeah, I guess it's also about the fire testing. So summarizing so far, mainly the tests were on the underground-based systems, or as you showed, the trough systems in Austria. Do you think that the different systems might generate different results? I think also similar questions that you kind of answered before. Do you want to add anything on that?
I saw some questions about the ivy. So the outcome of the test was not the aim to say don't plant ivy, because we are in full consciousness that ivy is not the classical plant for facade greening, but the ivy is the worst case concerning fire tests. So therefore ivy was used, not because ivy is the most popular facade greening plant. So maybe that's some kind of misunderstanding. Yeah. we put ivy into the test because it's the worst case concerning fire and fire testing.
Another question I was surprised about testing of hosta on facade. You mentioned is not a climber at all. Dislike a sun a little. It was in different system, green wall. I don't exactly understand this question. Maybe Miroslav can elaborate more on that question, and we come back to it.
Maybe it's mine, because I had hosta on one of my walls. I can remember I have like in my last burning test the hosta on the wall, but that was a mix of different plants, because we thought it's interesting to see how impact of different plants to each other, but we put them directly on the wall like you saw in the pictures. So there were no construction, no building components at all.
Okay, thank you. So another question. Ivy is the worst case limit case. Have you considered vertical systems with pockets and support cores like substrate? I guess it's they talk about the living wall systems with fleece. Whether you tested those systems, but I guess you answered it already that there were not testings on that in Austria or Germany. And could the ignition could happen in windy conditions? Do you think the fire will spread?
Did you watch my videos? They were outside, so of course it was July. But I'm honest, that was not a super hot day. There was wind out there, and the thing is, you have this giant chamber. That's the place where the power and the heat and the terminal, like you have all the heat coming out of the chamber, and the heat is not enough to to provide horizontal fire spread. So only the wind can like influence this. So we had sometimes wind, so we had a little bit horizontal fire spread. That was super interesting. And the good thing, what we could see and evaluate, no horizontal spread is like no uncontrolled no uncontrolled horizontal fire spread, because it stops. So the wind came, the fire started, and then you have this 10 centimeters gonna burn down. Okay, it's damaged, and then no fire going on by himself. That's what we saw in case of wind, because wind usually do like influence the horizontal fire spreading, I would say. Yeah, that's what I saw.
Okay, thanks. Regarding living walls again, do you know about the current situation on the regulations on a European level regarding the specifications that living walls must achieve, living wall systems?
In an European level, I would say that each country has to regulate it by himself.
But I think the big principles are always the same. Regulations depending on the height of the building. The higher the building, the stricter the regulations. Concerning reaction to fire glass, concerning fire behavior of facade systems.
Yeah, and you always observe the law, because, like I said, the state building code, that's how it's called in Germany, it's for the whole building, and because the greenery is attached to the building, only that's why you're talking about all these aims, or all the fire safety what it is required for the building. You have to follow the law and figure it out, and that's why you need still civil engineers who are really like into this topic. You need to read all the published paper, and then only this knowledge, that's why I call it recommendation. So you have published paper recommendation, you just try to summarize the whole knowledge about this fire performance of green facades, and then have a conclusion what's gonna happen on your wall. If you're not sure, it can happen. I mean, you're just a man, and you would need burning tests. That's what happened to this skyscraper in Munich, which I show while I show my examples.
Thank you. A question from France, I guess, whether the EU norm, fire norms for conventional wall and facade regulations are accepted in Germany and Austria as well.
Like all EU norms are accepted in Germany, yes. Sometimes we love to use Austrian norms, but it's like we can use them, but it's not a technical rule in Germany to use like different norms from other European countries. So we have only the German norms and the European standards.
And as I said in my presentation, we have no European testing standard, no harmonized testing standard for facade systems. Not for rear ventilated facades, not for attics, not for greenings. So now the situation is you have to do in every European country the national facade fire test. Austria and Germany are very similar. So if you test in Germany, according to the DIN norm, it's also accepted in Austria and in the other way around. But we are, for instance, not comparable to the Le Pier test of France or the British standard or the Norwegian and the Swedish standard, as I said it before. So that's also a big problem for customers of normal facade systems.
Like I mentioned about the future and current projects, only at the research project Fire Safe Green at the TU Munich University, they started use SPI testing to prove small like plants in small conditions. We are talking about 1 meter high, 1.5 meter in the wide, and that is something new. We are looking forward to see the results, to read about this. And yeah, they used SPI, so they could they decided once to use something different from other German standards, which we were talking today.
Okay. Actually, the next question is more from practice. So, away from the lab test that you performed, were there any serious fires involving living walls? And what were the issues identified to be at fault? So, in real life, basically.
Uncontrolled fire spreading, I mean, where you cannot save the people in the floor on the top. Like you have this big fire in your apartment, someone living like below you and of course on the top, and then you have of course to prevent any uncontrolled fire spreading on your facade. And the question is why the fire department's gonna arrive, but the main aim of them, they have to help the people first, and of course to take care of the fire in the apartment. It's not the aim, or not like the task to take care of the facade. And of course we're talking about equipment and all these problems. So we want to have safe facades everywhere in Germany and in Austria. And I think that's one important thing.
Okay, thank you. Regarding more arid regions, do you think there are big differences in regulations in humid or hot environments?
Mm. We don't have any experience.
Okay, so no experience on that so far.
I mean, it can be hot in Austria and Germany as well. That's why we started to put greenery on our buildings. So we're talking about hot environment everywhere nowadays. I mean, that was the driest year after many years. So it's hard to tell. I mean, and humid environment, I don't know. I don't think that in Britain you can, you need to still prove the fire, be sure about the fire safety of your building. Like we know about the tower in 2017. I mean, it was a big fire, right?
Another question was about actually the situation of, in general, actual fires happening on green roofs and facades in real life in Germany and Austria. Does it happen often? What is your experience?
Within our literature research, we also made an overview about fire incidences together with facade greenings. And I think there's a German statistic dealing with that topic of Mr. Brandwein. And I think he discovered about
54 in 8 years.
Yeah, thank you. Thank you, Julia.
No worries.
54 fires connected with greening in 8 years. And I think in Germany we have about 250,000 fires per year. But on the other hand, the argument against is now we have nearly no facade greening. What will be within the next years? And in Austria, we had a big fire in a castle where the fire went from the ivy, burning cigarette into ivy, from the ivy into the wooden roof. and the whole wooden roof of the castle was burnt down.
And I feel like every engineer, every architect who is planning a building, he shouldn't really like talk about statistic, because you're always planning your building for the worst case, and it can happen. So you need to be prepared, despite the fact what's happened to on other places.
Perfect, thank you. I think the last question before I just have two more comments. I guess there's a misunderstanding, but maybe you can clarify. The person said that the fire test seemed to be on plant mass, plant biomass that was cut, but not on alive plants. And if you think that if the plants were planted alive, the fire would spread less fast and would be less flammable.
I can say only one sentence. We cut the roofs off 5 minutes before we started the burning test. So 5 minutes, that was a live plant, I would say. It just because the chamber need to be open in this moment. That's why we cut the roofs.
This time period within our test was about 2 hours, I think, from gaining the plans, putting it on the test rig and doing the testing.
Okay. Okay, regarding the timing, I think there were two questions for especially Julia, just about some information about one person would be interested in the master thesis screening in front of exterior wall cladding made of wood. If that one is available,
not published
not
yet.
published yet, okay. And then another question, if there is a document available that summarizes the state of the art Standardtechnik concerning the knowledge about the fire performance of green walls. The FLL guideline for green walls, as they commonly...
No guidelines in Germany at all. And most of the documents, most of the documents you can find on the website of the Association Gebäude Grün. We try to provide you with all documents. So if they are not like for downloads there, you can still write the email and say, okay, I can download your summarized papers, but I need the official paper, the original one. They can help you always, like me and other people in the office can always provide you with to find the right paper. And the guideline, like something what you can open and see all the results summarized. It doesn't happen now. I mean, like you saw, there are 4 fire performance tests happened 2019, and we are still in process. So since 2021, they started the project at the TU Munich, and then they have a different project 2022 with the timber facade. So it needs to be published, all the results, then we can summarize them and maybe have some type of guideline. But still, it's difficult in Germany. They don't want to have like a guideline. They more try to show you like how to handle this topic, like what is the real experience. And of course, all this like ministries need one day to provide you with official guides. So that's a long process in Germany. We know this process, especially in timber construction. So we're building from like timber construction since years, but only nowadays we have a guideline. So it's a long process how they're gonna summarize the things and decide what gonna be their official regulations. They are not like set right now.
Thank you. Okay, then I think we're coming to an end. Thank you, first of all, to you, Dieter, Werner, and Julia, for sharing all your experience, all your knowledge, and interesting results. Thanks again for answering all the questions. Thank you to everyone also who joined today and was actively asking interesting questions to our speakers. And lastly, I would thank again all our sponsors, Jakob, Karstahl, Walgreen, Therapia Urbana, and GreenTex for making this session even possible. As I mentioned in the beginning, the session was recorded and will be available soon on our YouTube channel. If you have any further questions to us or to our speakers, don't hesitate to contact the EFB office. We will try to give our best and answer all the questions. And I will send out all the publications that the speakers will send to me to all participants. So yes, thank you for joining and thank you for being here. And I hope to see you soon in one of our upcoming sessions. We always publish them on our website, so stay tuned. Thank you.
Thank you, Isabel.
Thank you.
Thank you for listening.
Thank you.
Goodbye and take care.